coordinate geometry, Cartesian system. Rene Descartes, he was a great French mathematician. He solved the mystery of how do we identify the exact location of a point in the plane. And that is the reason why Rene Descartes is also known as the father of coordinate geometry. Now, coordinate geometry is a branch of mathematics that deals with identifying location of a point in a plane, or more broadly, location of lines and curves and different shapes in a plane. And it has tremendous amount of applications. So Rene Descartes, he was the first person who actually gave us how to define the exact location on a Cartesian plane. And because of him, this system of defining location of a point in a plane is also known as Cartesian system. So let's find out what did he suggest and how that actually works. So he first said that we will take two number lines and we will place them perpendicular to one another. Now we know what a number line is. Then he said that we will place the number lines in such a way that their origins coincide. I think they should be theirs, T-H-E-I-R. Their origins coincide. And then finally he said we will define the location of any point with respect to these two number lines. So now let's understand what he meant when he actually said this. So now, can these be the two number lines Rene was talking about? Answer is no, because they don't look like they are perpendicular to each other, right? How about these two pairs? Again, the answer is no. And finally, these two number lines, they look like they are parallel to one another. So Rene Descartes was not suggesting that our number lines will look like any of these three pairs. Now, what about this? This actually makes sense. They look like they are 90 degrees to one another. But like Rene said, we also need to make sure they are perpendicular and their origins, they coincide. So let's try and see how do we make their origins coincide. So if you get them a little bit closer to one another, and perfect. So here we see that the origin of our number line, the vertical number line and the horizontal number line, they coincide, and this is the point which is actually the origin to both the horizontal number line and the vertical number line, right? This point, which is a 0. Now it is convention to call the horizontal number line as x dash to name the number line, and the vertical number line as y dash, right? So all of the points on the x dash which are on the right, they are all positive. Similarly, all of the points which are on the y dash above, they are positive. And all of the points which are on x dash on the left side, they are negative. And similarly, these numbers, they are all negative, right? Also, we will see that x dash is also referred to as x-axis. As a matter of fact, going forward, we will be interchangeably using x dash as x-axis, and similarly y dash, the number line which is y dash, we will also see that we will refer to this as y-axis, right? So this will be the x-axis and this will be the y-axis. Now, and like Rene said, this angle must be 90 degrees. That means these two number lines, they must be perpendicular. So now, how can we locate any point? So we can take a point here, any of these points, maybe point on the number line itself. So Rene said that any point we can imagine on our plane, we can refer to using these two number lines. So what did he mean and how can we do it? Well, we'll just take a look at this in a moment. Now, quickly, if I were to ask you, can this pair or these pair of these number lines, can they satisfy Rene's criteria? An answer is yes, because Rene said the two number lines, they have to be perpendicular to one another. So these are all 90 degrees. These number lines are all 90 degrees. So any of these pairs will satisfy Rene's criteria. However, going forward, we will be using this as our way of showing the Cartesian system, where we will have the x axis as the horizontal line and the y-axis as the vertical line. Even though all of these are true, but it will be much more easier to have the two number lines drawn as horizontal and vertical instead of them being at these awkward angles. Now let's get back to how can we locate this point. I have randomly taken a point. How can we locate this point on the two number lines, which is the x dash, and y dash, or the x and y axis. So what Rene said was, he said first, we are going to find out the perpendicular distance of the point from both the axes. So what do we mean by perpendicular distance of this point? Let's call our point P. How do we find out the perpendicular distance of this point from both axes? Right? Axes are the x-axis and the y-axis. Well, we will simply drop a perpendicular from this point on the line, right? So for example, we will do something like this. The perpendicular distance from y-axis is measured along x, meaning how do we find out how far this point is away from this line or this number line? How do we find out? Well, we have to drop a perpendicular from this point onto this line, right? So we will draw something like this. So this is 90 degrees, right? So this, let's call this point as A. So this AP, this is 90 degrees to the y-axis or y dash, right? Now this distance, right, whatever the length is, and if you look at it, how far away is the point P from the y-axis? If we look at it, this will be the same distance as here, right? So this looks like it is 4 units away. So if you look from here, this is 4 units away. So we see this is 4 units in this example, right? And this distance is measured along the x-axis. How far is point P from this line, y-axis, is this distance, and this distance is same as this distance, right? So distance from y-axis is measured along x-axis. So we call this distance the x-coordinate of the point. The point we are referring to that is as point P. And this is 4 units away. So this 4, we call it the x-coordinate of the point P. 4 is the x-coordinate of the point P. Similarly now, what about the distance from this axis? Remember, Rene said we locate the point in relation to both the number lines. Now, how far is this point from x-axis? Well, that will be measured like this, right? So if you drop a perpendicular from the point P on x-axis or x dash, that will give us the distance. And how far is it? Let's call this point as B. So A is this point and B is this point. So how far is P away from x-axis, or what is the length BP? Well, BP is simply this distance, right? So this is 6 units, so this will be 6. In other words, we can think of this as a rectangle, right? So these two lengths must be the same, and this two length must be the same, right? So now the distance from x-axis is called as the y-coordinate. So then Rene said simply, now what we can say is that the coordinates of the point is within parenthesis, within bracket, x comma y. So what we say is that we have seen the x coordinate. So we say that the x coordinate, I'm writing x for short, x for x coordinate, is 4. And we see that the y coordinate, that is how far away it is along y, how far away it is along, it is from x-axis, measured along y-axis, is 6. So then we say our point P, we can refer to point P as within bracket, x for x-axis, x coordinate, y for y coordinate, and this will be actually 4, 6. So if we refer our point P as 4, 6, then this is how we can refer to any point on a given plane.